Hi guys, it's Mrs. Decker, and it is almost 11 o'clock at night on Tuesday, and so I'm going to record a video for you guys on isosceles and equilateral triangles since I'm not able to be there with you guys today. So this would be like our notes that we would do in class, so I encourage you to get out some paper and write down the examples that we do and the big ideas so that you can have that resource as you work through the practice problems. So this lesson is actually should be some review for you guys. We talked about these special triangles in our first unit of the year in the Get Ready for Geometry unit. So two special triangles that we're going to talk about. The first one is the isosceles triangle. And the isosceles triangle, as you can see here, is a triangle that has two equal sides. So I always remember it because isosceles starts with the letter I, and we have two eyes on our head. So isosceles, two equal sides. And because those two sides are equal, that also means that two of the three angles inside of the triangle are also equal. And the two angles that are going to be equal are going to be directly related to the two sides that are equal. So if I know that the sides with the tick mark, so AC is equal to the other side with the tick mark CB, then I know those bottom two angles, A and B, are also equal. And we call those equal angles the base angles because a lot of times they're on the bottom. Okay, so isosceles triangle means two equal sides, which means two of their angles are also going to be the same measure. Second special triangle is then the equilateral triangle, and the word in itself kind of tells you what kind of triangle an equilateral triangle is. That means everything's equal. So all three sides of the triangle have the same length, and all three angles inside the triangle have the same measure. So you see an example here, triangle ABC. All the sides are 8 units long, so they're all equal. And all the angles have to also be equal. And since we know that all three angles inside of a triangle have to total 180, we can just divide that by 3 to find that each of those angles is going to be a 60-degree angle. Okay, so two special triangles, isosceles, two equal sides, equilateral, all equal sides. So let's look at some examples. Let's first focus on just the isosceles triangle. So that the angle relationship, the two angles that are equal, and then we also have two sides that are equal. So in our first triangle on the left, our first goal says here to solve for AC. So AC represents the side of the triangle. So how long is it from point A to point C? And we see that there's 3 tick marks, those 3 little lines on AC. So that means that if we can match it to the side with the other 3 tick marks, and so that would be AB. So those tick marks, those little lines, tell me that AC is the same length as AB. And AB from the diagram shows that it's 9 centimeters long. So that means that AC also has to be 9 centimeters long since two of the sides are equal. And we're given one of the sides, we know the other one has to be the same. Now focusing on the angles inside the triangle, our next task is to solve for angle B. So I'm going to find angle B, and I'm going to put a little arch there. So angle B is right there. And so I need to know how many degrees that angle is. And they did give me one of the angles, angle A, they told me is 88 degrees. So that's definitely going to be important to use since it is another angle. And also keeping in mind that it's an isosceles triangle, two equal sides means two equal angles. Now, what angles are the two equal ones? Well, I'm going to use the sides to determine that. So again, those tick marks tell me that those sides are equal. So if I go across from that side, the corner or the angle across from that side, from both of those sides actually, those are going to be my equal angles. So angle B and angle C are going to be the exact same measure. Okay, and I know all three have to be 180. So let's subtract the 88 angle. So I'm going to take the 180, my total. I'm going to subtract, take away the 88 degrees that we already have, and that's going to give me 92. So that tells me I have 92 degrees left in this triangle, but I also have two angles left. So I have to take that 92 degrees and I have to divide it by 2. I have to split up that 92 degrees that are left between those two angles. So 92 divided by 2 is going to give me 46 degrees. So angle B is 46. I'm going to clean up my picture here so I can label it. Angle B is 46. And that also means angle C would also be 46. And then from the first part, we found that AC is also 9 centimeters. Okay, so we've kind of got two worlds going on in this problem. We've got the sides to think about, the numbers on the outside, those kind of all go together. And then we have the angles, what's inside the triangle. We got to keep those numbers together. Okay, so make sure that you think about the sides as one world and the angles in another world, and we don't want to combine a side with an angle because they're not like terms. Okay, looking at the second example, you should definitely see that we've got some variables involved, which means we're going to have to use some algebra skills. So same ideas, we're still using the same relationship of two sides are equal and two angles are equal, but we're going to have to use some algebra, set up an equation, and then solve that equation. So first part says solve for BC. So I'm going to examine my triangle here. And if I'm trying to find BC, well, that is this side of the triangle. And that side, because there's these two tick marks, that's going to match side AC, because that side also has two tick marks. So I know from the triangle that this is isosceles and that BC is the same as AC. And so BC is represented by 2y plus 19. So I'm going to substitute that in on the left side, and that's got to equal 4y plus 5. Okay, so I've got the two equal sides set equal to each other, and now I just need to solve this equation. First thing is I've got y's on both sides, so I need to, let's take away these two y's on the left, and we got to do it to the other side too. And so we cancel those out, and we're left with 2y plus 5 equals 19. Now I can just do a two-step equation here, get y by itself. So let's get rid of that plus 5 by doing the opposite. And that's going to leave me with 2y equals 14. And one more thing to get y by itself, we'll divide by 2. And so we get the y value of 5. All right, so we solved for y, but we need to plug that back in because the question asked me for BC, not just y. So kind of the last part here would be to plug that y value back in. So we know BC is 2 times y, which is 5, plus 19. So that's going to be 10 plus 19. And so we get, oh, hang on, I made a mistake. 14 divided by 2 is not 5. It's late. Sorry, guys. 14 divided by 2 is definitely 7. So then when I plug that back in, I'm going to do 2 times 7 plus 19, which is 14 plus 19, and that will give me the 33. So BC is 33 inches or units, because we don't know the units, so we'll just write units, 33 inches long. Okay, so that was our sides world, right? We were focused on the sides. Now we're going to switch gears and we're going to solve for an angle. So angle A. All right, so angle A is 6n plus 15, and we know since it's across from the equal sides that angle A has to be the same as B. So A is 6n plus 15. That has to equal 9n minus 9. So this is going to look very similar to how we solved the first part. Again, we've got variables on both sides, so let's take away the 6n from both. And that's going to give me 3n minus 9. And then add 9 to both sides. So 3n is equal to 24. And I'm running out of room, but last step, divide by 3. And so n equals 8. So I know what my variable, the value of the variable is, and now all I've got to do is plug that in for A. So let's put that up here. Angle A is going to be 6n plus 15, and now that we know n is 8, 6 times 8 plus 15, and that's 48 plus 15. And so what do we get there? 1363. So angle A is 63 degrees. And so if A is 63, we know B better also be 63. And we could check that 9 times 8. 6, 7, 8, 72. 72 take away 9. Does that give me 63? That looks good. I could even go one step further and find C, since that's the last angle left. Let's see, what colors should I use? Gosh, I've used almost all of them. Let's do this lime green color. So angle C here, that's our last angle. So we've got 263 degrees, so we could add those up. That's going to give me 126. I got to get to 180 altogether, so let's subtract that from 180. 10 minus 6 is 4. 7 minus 2 is 5. So 54 degrees would be that last angle, if they asked me to find that one. Okay, so that's isosceles triangle. Again, 2 equal sides means 2 equal angles. The angles across from the equal sides are going to be the equal angles. And then remember to keep your sides together and your angles together. Keep those worlds apart. And then we'll finish up here with an example of an equilateral triangle. So recall, equilateral triangle means all the sides are equal to each other, and then all the angles are equal to each other. So number 1 is asking us to first solve for x and y. So I'm going to start with x. And x is right there. It represents a side. It represents side BD. And since it's equilateral, we've got tick marks on all sides of this triangle. That means all the sides are going to be equal. So BD is also going to equal AB. That's also going to equal AD. Okay, so 3x minus 1 must be 13. And then solving this equation, just a two-stepper, 3x equals 14. Ooh, dividing by 3, that's going to give me a decimal. So I'm just going to leave it. I'm going to leave it as an improper fraction. If you don't like that and you want to divide it and get a decimal, that's fine by me. But I'm going to leave it 14/3 because now I need to find how long that side is. But wait a minute. We already know how long that side is. So we really don't need to plug it back in because we already know it better be 13. All right, so that's the sides. Now let's focus in on the angles. So angle Y here is 5y, angle D. We know since it's equilateral, everything's equal. So angle A is equal to angle B, which is equal to angle C. And we know all of those angles have to be, each of them have to be 60 degrees because that's the only way we're going to get 180. So 5y must be 60 degrees. So 5 times what number is equal to 60? 5 times what is going to give me 60? Or we could divide by both sides by 5. 60 divided by 5 is 12. So y is 12. And angle A must be 60. Okay, so that's equilateral triangles. Set the sides equal to each other. And then the angles we know have to be 60. So angles inside of a quadrilateral have to be 60 degrees. So you know that, even if it doesn't tell you. All right. So we talked about 2 types of triangles, isosceles and equilateral. If you could, go ahead and work on some practice problems in Schoology. And remember, guys, I'm checking my emails, so if you've got a question that pops up, please send me an email, and I'm going to do my best to be checking that throughout the day, and we'll get right back to you. Hope you found this video helpful. Hope you learned some things about isosceles and equilateral triangles, and I hope to see you guys soon. Have a good day. Bye.